This will be an interesting talk. It's a little bit different than the ones that I usually do. Usually I'm doing talks around like open source tooling or more principle based. This one is really heavily around CodeFresh and kind of our philosophy and approach to CICD. So it's a little bit different for me. We'll get into introduction. We'll talk about the CICD definition, which is shockingly abused. And then we'll get into the 13 features and we'll do some demos. Was it, no, it wasn't Caleb, as Greg. I messed it up.
Yeah, it was me.
Yeah, Greg. Okay. As Greg had said, I am a Google developer expert and a member of the Forbes Technology Council. You can follow me on Twitter @TodayWasAwesome. Taryn knows that the only reason I do talks is because I'm trying to boost my follower count. I want to be an influencer one day, really hoping to be that important of a person. So that's where I'm trying to go. So you can follow me there. All right. Anyway, I also want to give a shout out to Anna Baker, who couldn't join us today, but she actually wrote the book 13 Key Features Every Modern CI/CD Tool Should Contain, and would direct you there to read what she wrote. She's really amazing and did a great job. She's an evangelist emeritus for CodeFresh. So, all right. So first off, let's talk about what CI/CD actually means. And CI/CD is a term that has been incredibly abused. People are like, oh, this is a CI/CD tool. This is a CI/CD tool. This is a CI/CD tool. And they don't stop to talk about what the heck that actually means. CI/CD isn't a description of a tool. It's a description of a practice, right? Continuous integration is the idea that you are testing all of your changes and merging them into a branch as you go. So it requires version control. So by that method, version control is actually a CI/CD tool because it's a prerequisite for you even to do it, right? And CD is continuous delivery. This means that as changes are tested and as they're validated, that everything is done up to the point where you're then given a button that you can push to deploy. And then CDP is continuous deployment. This means that once a commit is made, everything is completely automated in order to the point where you actually deploy it. And so you should think of CI is actually a subset of CD, which is a subset of CDP. And oftentimes people talk about this and they're like, we do CI and CD. There is no and. There is CI, there is CD, which includes CI, and there is CDP, which includes both of those things. And the test is, and this is what you should think of. If you think you do continuous deployment, if you're not sure, this is the test you should ask yourself. Can I make a commit in Git and go on vacation and everything was deployed and it was fine? Because if that's not the case, then you're not doing CDP. So if you're one of those companies that has like a no deploy Fridays, I would argue that you're not doing CDP. Because, and think about what that means from a tool perspective. It's not about a tool necessarily. It's about having confidence in what you're doing. And getting there requires, yes, some tooling, but it's difficult. And if you think about it from a best practice standpoint, like a bash script could be a CI/CD tool, right? It's just, oh, I put everything into bash and I'm super confident in it and I commit it, and then a bash script runs and runs all my deployments. I don't even check it into code. You know, it's all local. That could be continuous deployment. It'd be terrible. In the same way that you could use Excel to make Pac-Man. It's a terrible idea. It's neat that you can do it. Are you going to be happy that you did it that way? Probably not. But it would be cool to show your friends that you made Pac-Man in something that was clearly not designed to have Pac-Man. So that's kind of the brief intro to CI/CD, and I think that this as a term has been pretty heavily abused. I hear people often talk about, oh, this is a CI tool, this is a CD tool, and really it's like, okay, well, it's only that tool insofar as it helps you accomplish those tasks, and does it help you actually do that? So that's what we're going to get into. And with CodeFresh, the way that we think about this is there's a bunch of stuff that happens from the moment you write your code to the moment you deploy it. And that's the continuous integration, continuous delivery loop. And really, this is the build and delivery loop. And actually, for any company, this is the most important function in your company. I can't think of a company that's not that way. I suppose if you just, if you had no technology in your company at all, it might be different, but that it's almost easier to make a list of companies where this isn't the case than to make the list of companies where it is the case. It's pretty much everywhere. Your engineers are almost always your most expensive resource, and making your engineers more efficient is the entire purpose of your build and delivery loop, in addition to ensuring a better level of service. And if you need help making the business case for that, I gave another talk called Making the Business Case for DevOps, which I would recommend you check out. And I think Taryn will probably drop it in the chat. So that's kind of the scope of what we're talking about. So feature number one, we're talking about modern, and that means that your tool should be container-based right from the start. And container-based architecture is something that, while it is sometimes viewed as new, it is something that solves so many problems. I actually gave a talk all about this one feature and just what it means and how, and we could spend an hour and a half on it, and why it's so important. But most tooling that exists out there today is VM-based. And VM-based tools, and if you're using VMs, especially for your pipelines, that means you have to maintain infrastructure in a way with containers that you don't. And so if you think about this, there's kind of two different models on the right-hand side. The top one represents a build node, which is sort of the VM model, and you might have to install a bunch of different tools on it, and you have to maintain the tooling and the versioning there. And so you might have things like, oh, I've got I've got this test suite that uses this version of Python, and my app uses this version of Python, and oh no, now I have a conflict in my VM. So I need to either reconcile the conflict, or I can invest in a version manager, which there are a lot of tools that help you switch versions and stuff. And this is all basically because the architecture isn't designed for the kind of cloud native modern development that we do today. There was a time when people were monolingual shops, right? And maybe that still exists. I don't want to give you a crisis of an existential crisis if I describe your organization and I say it doesn't exist. But when I started engineering, the company I was working at was a .NET shop, and everything was .NET, and they were sure that the future was all about Silverlight. That was the future, and everything was going to be Silverlight and .NET. And if anybody wanted to build something different, gosh darn it, they should go work somewhere else, because we don't do that multilingual nonsense. And when that was the case, having a VM based or even a bare metal based build infrastructure wasn't that big of a deal, because everybody had to speak the same language. That's not the case anymore, and all of these things have complex interdependencies, so it's difficult to do. So containers are actually a de facto standard, right? They're not tied to any vendor, and they're available anywhere. So you can go on Docker Hub or GitHub's Docker registry, and you can find pretty much any image that does whatever job or has whatever tooling you need. And it's about more than just the idea of having a container as a step. It's about making a container a single function operation. And so it contains everything it needs to do its job. So this makes it really easy to work with. So you can see on the right-hand side, there's this build context, and it's like, oh, well, this run runs Node version 9. This one does the AWS CLI image. This one does the CF Helm, and then it has these actions that are doing. We can actually go beyond that. And the cool thing about that is that it also means that you don't have to have any special domain specific language, that you have to know and work with that. Abby says, struggling with coordinating deployment of code in SQL dependencies with Windows and MySQL servers. Yeah, well, the dependency issue here is can't be understated, right? That's like a big deal. And by using containers, you can isolate all those things so that your dependencies never interfere with each other. So that's like pretty critical. And the way we do this in CodeFresh is every single step in your pipeline is actually executing its own container, and then they have a common volume that attaches to each of those. And this allows you to send information between steps without having to worry about version conflicts and stuff. And this screenshot on the right is something that a customer actually sent me, where they basically took a whole bunch of logic that they had built into a pipeline, and they just put it into an image. And they said, we're going to just have this logical step just be one image, and then we can just use it over and over again, and we just reference it. It's like object-oriented programming almost, right? You're making this object and you're using it. And what we found is that people not only understand pipelines much faster, but they build and maintain pipelines much, much faster. And I think Greg is echoing this. He says, we just made custom containers using Flyaway and trigger them as Helm and pre-upgrade jobs. Yeah, exactly. Using a container to do this makes your life so much easier. Abby's wondering about handling PCI compliance. And when you're running a container, this isn't necessarily a huge issue. I mean, if you're just pulling random images off the net, maybe, but building your own from scratch, or just taking a Docker file that exists out there and then building it yourself and keeping it on your infrastructure, that can help you maintain compliance. But happy to have other people from the group chime in on that one. Number 2, you want it to be cloud and version agnostic, version control agnostic. And the big issue here is that if you look at version control providers and cloud providers, they all have their own CI or CD tools, right? So GitHub has GitHub Actions, along with Azure DevOps. Azure has Azure DevOps. GitLab has GitLab CI. Google Cloud has Google Cloud Builder. AWS has AWS Code Pipelines. Bitbucket has Bitbucket CI. So there's all of these different kind of add-on tooling to help you do stuff. The big issue with this is it tends not to work very well in large organizations because people usually aren't anymore getting locked in on a single platform. So most people I talk to, most engineering organizations I talk to, once they reach a certain size, there's no hope of keeping them 100% AWS or keeping them 100% GitHub or GitLab or whatever. We see as organizations grow, they tend to expand onto different tools. And if you are using everything in AWS, that's nice if you're only ever going to do anything AWS. But when the bill comes next month, your CFO might be demanding that you start negotiating harder, and you can't do that when you're in a position where you're completely locked in on the vendor. I remember a few years ago, I think it was about 6 years ago, Apple had basically everything stored on AWS. And then it turned out to be a real bummer that Apple's biggest competitor was like Amazon. And so they moved a bunch of their infrastructure onto Google Cloud because of course they weren't going to put it on Azure. And it turned out that all their competitors were the people doing the hosting, right? So you don't want to be in that position, and you don't want to be in that position from a code-based standpoint either. Just because your code is managed in one place doesn't mean that those teams know how to make the best CI or CD tools. So that's number 2, is that you want to definitely have flexibility there. You want to have a tool that's going to work with whatever code provider you put in front of it, and it's going to work with any cloud provider you want to put in front of it. And especially something that we've seen a lot of is and I won't mention the name of it because YouTube will ding this video and it will make it harder to find, but there's a thing going on in the world that's like pretty big deal, and it's like changing the way that people are living and stuff. And we actually ran a survey on the impact and found that people were moving much more aggressively to cloud, and that a large component of people were keeping some components on-prem because they wanted to have kind of a fallback failover, but they wanted all the flexibility of the cloud, and they're all trying to avoid vendor lock-in. And if you go with a single vendor lock-in tool, then that's all you're going to get. So that's going to be difficult. And it's also going to make it more difficult for, let's see, I'm trying to admit all the people. Hang on. Admit. Okay, there we go. So yeah, you want to have a tool that avoids that, and you don't want to be beholden to just your code provider or just your cloud provider. So number 3, you want something that has a standardized pipeline creation, and you want something that has definitions like resources as objects. And I'll explain what that means and how we do it. So on some platforms, you can use several different kinds of ways of defining your pipeline. And it's like, oh, well, it's cool, it's flexible, but you actually don't want that flexibility. And I'm going to put flexibility in quotes here because what it means is that you just have a more complex structure and it's harder to do things. If you have a very clear defined, this is the YAML, this is how it works, and then I can create images that do jobs, a specific task within my pipeline. This makes your pipelines easy to create and maintain, and helps you avoid getting stuck with something that's potentially overly complex and unmaintainable, and especially like different. You don't, when it comes to defining things, you don't want to have a whole bunch of different ways of defining things in your workflows, because as people move between them, they'll get stuck and confused, and that's when problems happen, right? Another thing is here, you want to make sure that everything is stored in source code. So we've been really heavy on the GitOps train since that started about 1.5 years ago or 2 years ago. Oh my gosh, is it 2.5 years ago now that it really started? Anyway, time flies, but you want to be able to define everything to do with your pipelines and your configuration as code and keep it under version control, so that you want to treat it as nice as you treat your code, right? Keep it under version control. The other thing that I think is really big, and this one is a little bit more rare because some of this stuff is like, well, yeah, obviously, but one of the things that I see a lot is people that have to define all their resources in a pipeline. So if they wanted to deploy to a Kubernetes cluster, they have to add a bunch of credentials and things in there. If they want to pull from a Docker registry, they have to add all those credentials. And then when they go to, create additional pipelines or things like that, they're copying these things through, and then maybe they're creating different resources, and it gets really hairy really quickly. So one of the things that we did in CodeFresh is we created this universal kind of layer, and there's permission sets around it and things like that. But basically I can add my cluster to CodeFresh, and once I do that, I can just reference it by name. So when I go to do a deployment, I just say deploy to cluster name, and then all the permissions and everything is happening behind the scenes. And that includes stuff like how we connect to the cluster. So do I have to open up my cluster to the whole internet in order for me to be able to deploy to it? I'm not feeling really comfortable with that. Makes my insides a little unhappy to stick the Kubernetes API just exposed to the internet. We have a mechanism where you can do this behind the firewall. And from a pipeline definition standpoint, you don't care. You're just saying deploy to the cluster. And then you're just using the universal kind of way that you've defined how to talk to the cluster. So that makes creating these much easier, and you can make them more modular, right? So you can create a pipeline once and use it over and over again, which is one that we're going to come to. Number 4 is you want to have a visual pipeline view. This seems like a no-brainer, but there actually are tools out there that don't have any visual view, and sometimes I'll see people that are just like, oh, it's all just in bash scripts, I got it handled. And it's like, okay, well, that's great because you can understand what's going on and no one else can. And that's either really good job security, or depending on your org, it's really big job insecurity because they don't want to keep something around that looks like a black box, right? So within this visual pipeline view, there's actually more that should be available, right? The objective is any stakeholder, and this is actually something that I see much less than I would like to. Your product managers should be looking at this stuff if they feel like it, right? They should be able to look in and see what's going on to this level. And if they're not, it might be because it's just too inaccessible for them. So you want to have something that's really accessible. And then you also want to have all the information right there. You want to see what YAML was used to run this pipeline, what pipeline definition, right? What are the logs from it? What's the state as it went along? What are the commits that were taken for this build, and how do I get back to those commits? How do I see the diff of those things? And then you want to also be able to organize it for clarity. And sometimes tools will let you do this and sometimes they won't, but you want to be able to set up visually your pipeline in a way that makes a lot of sense. And it's not just a linear progression of things or things like that. You want to be able to stage it out. Number 5, you want parallel steps, and you want to be able to look at step dependencies. So this is what we call fan in and fan out. So the idea here is that I can define a step, and there's really 2 big points. One is cost efficiency, right? So if a pipeline takes 5 minutes to run and it's 5 steps, a minute per step, if I can run those in parallel, then I have 5 minutes of worth of steps that take place in 1 minute, right? And anytime you can do parallelism, this is super important. It's super valuable. Because it's going to lower the time that people spend on builds. And build time cost is actually very, very high. We did a calculation on this a while ago. We found a lot of organizations could save hundreds of thousands, if not millions of dollars a year just by shaving, a few minutes off of their build times, depending on the size of your organization. We have a calculator for it. It's really interesting. So why is it so expensive? Well, because I, as a developer, I make a commit, and then I'm looking for feedback on that commit to make sure that everything went smoothly. And if your build or pipeline time takes a long time, that person's just sitting there. Or maybe they're off playing games, or maybe they get up to go get a drink or whatever. Maybe they needed a break, in which case, that's fine, whatever. But more often than not, people, lose track, they wander off, and then they have to get back into the groove once it's finished. And sometimes these things take a long time. And that's the kind of other component, is that the faster they get feedback, the more confident you feel in committing and making changes and moving forward, right? When it takes a long time, every change feels really hard. But when it's really fast, you get the feedback immediately, then you make commits faster, you move faster, right? We actually did, we had a customer, some users that gave a talk at KubeCon last year, and they reported that they cut their build times from 1 hour and 40 minutes to less than 12 minutes. And so think about like how much savings that is. Like 1 hour and 40 minutes is like, oh, I can just go watch a movie right now. You don't want people necessarily going off to watch a movie in the middle of things. And I think Craig just shared this. Craig, is this the one I'm thinking of? Yeah, it is. It's the XKCD where they go off and they're oh, it's compiling, so I can go slack off, right? You don't want people, you want people to have fun at work, but let them just, have the fun, not because the tooling is crap. I actually saw one time I was visiting this company where I was going to lunch with a friend, and this was a big, like, Fortune 500 company. And the engineer next to this person I was visiting had 2 computers on their desk. And I was like, whoa, this must be a real engineer. They got 2 keyboards. They can do in parallel. They're coding twice as fast as everybody. He said, no. Actually, every time they run a build, it makes everything stop working for the next hour and a half. And so they hit build, and then they shift over here and start using the other computer so they can be efficient. And I thought, I don't know if you've ever heard of build systems, but they don't have to be on your desk. They can be disconnected so that your computer will still work when you're doing them. And that fan in, fan out thing that I talked about is about dependencies, right? So instead of just saying, do X, do Y, do Z, and if any of those fail, then fail the pipeline, you can do things like, in order for Z to run, X needs to be completed, and X can have its own dependencies. And this allows you to create essentially policy around how steps should progress, right? And that policy becomes the modus operandi for the organization. So it moves smooth. Everybody knows how it works, and the dependencies are clearly marked right in the visual pipeline. Number 6, standardize extensibility on containers. I labeled this, you have one job. So that means that rather than plugins, plugin architectures in general are really terrible. And for reference here, I'm thinking of Jenkins more specifically. And I don't want to, club anybody's baby or anything, but if any of you have ever had the experience of like trying to upgrade a plugin in that platform or many other platforms, oftentimes they conflict with each other in really unpredictable ways. And so you'll go to use a new version, and then it breaks a bunch of other stuff because they're not working off of containers. So they don't have isolation. So it's like, oh, in order to use this plugin, you have to have that plugin, and you have to have this plugin, you have to use that plugin with this version. And if you use the newer version, then that breaks this other plugin over here. And all of a sudden, you've lost your weekend because you're trying to upgrade everything and make sure it all works together, and it doesn't work. But by having containers be specialized, so for example, you can see an example. These are all open source container steps that we have available in our library, codefresh.io/steps. And you don't have to use them with CodeFresh. You could potentially take some of these steps and you can use them on your own. But it's like, this is a container, this is an image that knows how to deploy to AWS Lambda. This is an image that knows how to open a GitHub pull request. And that means it has all the tooling it needs to go in there. And so you're just passing in the argument of what it needs to do. So they're like functions, right? Except they have way more isolation. So they're more like microservices, right? And this is really nice too, because if you can just create containers, that means developers can all create their own plugins, right? They don't have to have any special knowledge, any API or any language they need to know. They can do it however they want. You can also reuse the existing plugins from other teams much easier, because sometimes a team will develop a plugin and it's dependent on their own configuration and versions and all these other things. But if you do it as a container, that's much less likely. You're basically just mounting in a volume and doing work, right? And using any language is super valuable. I often see people will be like, well, I'm going to use Bash because that's universal and I can just always use Bash. Even though it's not, because it's kind of abstracting different versions of stuff underneath it. But if you can write it in Go, write it in Go. If that's the best tool for the job, use the best tool for the job, right? And of course, any public image is potential step for your pipeline. And don't get me wrong, especially if you're doing PCI compliance, you should throw those into like image scanning and stuff and make sure that you're following compliance policies. But it's pretty easy to rebuild Docker images yourself and stay compliant. So that's really nice. All right, number 7. Everything, and I mean everything and everything and everything, should be configurable in both the UI and in the code. So this is not just the pipeline definition, but your resources, your policies. You should be able to manage your secrets. You should be able to do all that stuff either as code that you can check in. Don't necessarily check in my secrets, or at least through a CLI or something like that. And so this is something that you can do in CodeFresh. So you can see in this one window, I ran a CodeFresh Git pipeline runner simple output YAML, and it gives me the entire pipeline definition as YAML, including the triggers associated with it and all that kind of stuff. I can potentially update variables if I need to, or I can not store those as code if they're secrets, or I can integrate with Vault or something like that. This is pretty critical, because if you're just clicking around to do everything, then you can't put it under version control. So if something changes and it breaks, you have no idea that that happened, or you're kind of at the mercy of the tool. And there are a lot of tools actually out there, believe it or not, that are purely graphically based, and they don't have any kind of way to export your configuration and put it under version control. Caleb asked, does making a change through the UI open a PR? That would be rad. No. No, not necessarily. So you can lock if for the people that are using CodeFresh and they lock and they put everything into the UI, they basically lock it down so you don't edit it in the UI, and it's only using the source code, or there's a pipeline that actually applies the changes when you want to make the changes. The UI is nice because when you're building something that's new, going and restructuring a whole YAML, like all this stuff, it's kind of difficult, but so you want to be able to do it through the UI, and that includes even like writing the pipeline. So like in CodeFresh, you can actually go in and write your pipeline right in the UI. You can store it in the UI. At some point, you know, as you are ready, you should move it under version control, right? And GitOps to me is always been like a North Star. It's not a binary standard. So people will be like, well, you store your secrets in Vault. That's not very GitOps because there's not version control really in Git. And you're like, yeah, that's okay, you win. It's like, congratulations, you're the same person that's like, that's not really serverless because you know there's actually a server under there. Like, yeah, no, I know. I know there's actually a server like somewhere. I just don't have to care about what it is. So like with this, it's graduated, right? So like my pipeline definition, you know, that's 1, right? That's like level 1 is like, let's get that done. And that being done is probably 95% of the battle. Some of the variables, you know, maybe I integrate with Vault or something. But then within the definition of things, being able to do it programmatically is potentially useful because what if I want to add and update clusters on demand on the fly? If I can't do that through code, then I can't do it in an automated way, right? So it's also about the extensibility. Greg asks, does CodeFresh have native support for secret variable values? Yes, sir, it does. So you're actually looking at here a screenshot in CodeFresh where you've defined a variable at a pipeline level, and there's encrypted secret there. And it will also automatically filter those out when you're in your pipeline logs. So if something tries to echo out the secrets values, it'll actually remove it so it doesn't get spammed into your logs, which was always a problem with like AWS keys and like Terraform, right? When you throw up your plan. So yeah, and then, and this is kind of a side note, but this can be scoped to a pipeline, to a project, and to an account. So you can actually scope it out and lock it down to the permission level that you want. Number 8, reusable pipelines for microservices. And this one is like a total lifesaver. So think about it this way. The kind of classic way of doing this is one service, one repo, one pipeline, right? And my pipeline definition is thrown into Git in the repo with the service that it goes to. And every service I add, I drop the pipeline in there. And that sounds really nice when you have a couple of microservices, but when you have 5,000 microservices, and like most of those pipelines are like kind of the same, and then you want to add like a security policy, now you've got to open up like 5,000 pull requests, and now it sucks because they've all diverged to become different, and you're trying to reconcile these things, and it becomes a nightmare. There's no centralized way to approach it. So the way that we really recommend, and we've seen this work really well in a lot of places, and I'll actually show you, yeah, I'll show you one, is think about your triggers as separate from your pipelines. Your pipeline is just a definition of process, right? And you could also think of it as a definition of policy, right? So triggers can bring all the information that's needed for the pipeline to do its job. So if I do a git commit on repo A, when it executes the pipeline, it says, hey, I'm a commit from repo A. And in your pipeline, it's like, check out the code, do a git checkout from whatever repo triggered this, and it checks that code out, right? And then you can go and execute from there because you've pulled in the Docker file, right? So you know where the Docker file is. It's always on this part of the account, right? You know where the Helm chart is, you know where all those resources are, and you just follow it a templated way, and it's very straightforward because you can define your pipeline once and maintain it in one place, and everyone can just have access to it because when you add a new microservice, you just add a new trigger, and that makes it really easy. It's updated once, it's reflected everywhere. And this is actually a screenshot of how we do this internally. So this is actually the CodeFresh platform is built up of a complex microservice stack, of course. And what you can see here is that these are all the different triggers associated with this pipeline. And again, I can define all of these as code, right? So I can programmatically add thousands of repos and triggers, and I can handle commits and pull requests and all these different things. And you can see each of these triggers has like branch filtering on it. I can deal with pull requests. I can do all those different things. And I can have triggers that are based on an image being pushed, or I can have a trigger based on time or whatever. And then the context basically passes into the pipeline. And this is huge. This is really, really valuable. And we've seen, like, I can't tell you how many people I've seen who are like, oh, I used to have to maintain like 1,000 pipelines and it was a nightmare. And now I'm maintaining like 4. I just, and the way that we actually did this, and there's a whole talk about this, which I think is called CICD for microservices, I think is what it's called. And it's all about this basically. But by relying on the context, you can conceptualize all of your processes in a singular way. So what does that mean? Like for here, we have one CI pipeline. And all of the builds and all of the tests before something is deployed are put into this one pipeline, and they all everything just follows the same kind of format. So I can just throw all my repos at it. And then we have another pipeline that's just for CD. So that one's actually triggered. The way we actually do it, and this is kind of a side note, but it's like the GitOps way of doing it, is the CI pipeline actually opens up a pull request onto a repo that has all of our Helm charts in it. So it's a pull request to modify whatever its Helm chart is. And then a pull request to that fires off our CD pipeline that will then deploy it to a fresh environment, run all of the integration testing and things like that. And then once that passes, actually deploy it automatically, right? And then merge it accepts the pull request, merges the pull request, and then deploys it automatically. So that one's really nice. Number 9, live pipeline debugging with breakpoints. And this one's actually fun. This is the first one that we'll actually do like a real demo on. And I say that you should treat your pipelines like you treat your code. So if you think about it, like you've been building code for a long time, and it's invaluable to be able to set breakpoints and be able to interact with your code in real time. And like every editor lets you do this, but no one's ever done that with your CI/CD process before. And so you get stuck in these loops where you're like, I think this is what is going on, but I can't tell what the context is changing. And like, I'm trying to figure out what versions are running. So I'll show you what this looks like. I've got a pipeline pulled up here, and here you can see this is a debug example. The pipeline's called services, and it's got 2 stages, stage 1, stage 2. It runs a Redis instance, so I can actually access that from all my steps. And then for each step, you can actually see that I've just defined an image and a command. Now, I'm actually not using in this pipeline any of these steps, which like if we were to look at like like an approval step, let's like an Argo CD rollout. This one actually is a typed step rather than an image-based one. So a typed step just has arguments. So but behind the scenes, it's basically just a Docker image with a schema, and then it will just execute as you expect. So I'm going to go ahead and run this. And I'm going to run this in debug mode. And in debug mode, this will allow me to set breakpoints where I want to stop and do something. And so I'm going to add a breakpoint during each of these steps. So the override means that I'm actually going to interrupt whatever the container was going to do, and it's going to drop me into the container. So if I ran it before, I can access the volume, but I won't have access to the tooling inside the container, right? And this actually brings a lot of the stuff together. So we talked about container-based pipelines. Like, what does that mean, and how does that work? So you'll actually see it in action here, and you'll also see the steps happening. So this one. Oh, I thought I meant to tell it to run concurrently. I must have not done that. Oh, well. All right, so I'm here now in my volume, and I can see all of the things that are going to be part of the shared volume. So I can actually, I'm going to make a file called Golang just so that we can see it later, so we can see it. And if I try to run Go version, I'm good to go. If I try to run Java, I won't have it. If I try to run .NET, I won't have it, right? So I'm going to hit continue. So it's going to move past the breakpoint, and now it's going to spin up this Java container. I should have done these all as concurrent steps, but I didn't, so my bad. So here now, if I try to run Go version, of course it doesn't work because I'm in a Java container, right? So now I can run my Java stuff, which I think, I can't remember how Java does this. Java, do you remember how to use Java?
It's uppercase V.
Oh, is it uppercase?
This is hilarious. It's dash version.
Mm.
It's different than any other command out there. Yeah.
The lowercase.
Lowercase v. No.
Sorry.
Aha!
Yeah.
You can tell
I curse
really
Java every time.
I don't ever write anything in Java. So yeah, we can see that Java works, and of course .NET won't. And if we look at our volume, we can see that we've got the Golang in there, right? Because this is actually working off of shared volume. Now, what's cool about this is in this case, it's actually working off of one Kubernetes node, and it's attached an SSD from that node onto the pipeline, and then each container is executing as its own thing, but it's attaching to that SSD. Now, why does that matter? Well, build times is the big answer, right? That means that IO is going to be wicked fast. And of course, if I continue on, we'll get into the .NET container. Now, at any point, I could actually access the Redis instance, right? Because that's a service that's running in my pipeline. So we can just see that .NET is installed. .NET. I think .NET is, oh, .NET. You can see me mess around with trying to figure out what versions are and everything. Of course, the volume is still there. But let's go over to the Redis one. Now, this Redis one, actually, this is just a bare image that doesn't even have Redis installed on it. So in my steps, what I would need to do, oops, sorry. What I would need to do is actually install the Redis instance. So let's see, I would do apk update add Redis. There we go. Redis is installed. And now I can use the Redis CLI and Redis CLI, Redis. And I defined all this at the top right, my path and my host name and stuff. So it's basically running almost like a Docker Compose right now. Did I do it wrong? You know what? I'll just copy and paste it because I wrote it down earlier, and typing live has never been my strong suit. There we go. And then you know, I'm interacting with it, right? So this is cool because it basically means you can build your pipeline almost like in real time, right? So you can actually see the state of things. You can explore the volume. You can make sure the tooling's installed the way you want to. And when I first started using this, you know, building a pipeline for me would usually take like, I mean, let's be honest, like a couple hours. And now when I do it, it's like minutes, like 15 minutes, because I just know what's going on. I'm just like, oh, I'm gonna drop in this and that and the other thing, and then run it in debug, and then like just kind of step through it manually once, and then it's like, oh, okay, I need to tweak this, that, and the other thing, and then run it again, and everything works fine. So that's live debugging. It's invaluable. I can actually also access my shared resources. So in terms of my environmental variables, check this out. I just ran my env, and you can see actually all my kind of different available options here, like my build URL and stuff like that. So this is nice. And I could actually also access my resources that I've connected onto my account level, or anything that I have permissions to. So that could be like Kubernetes clusters, or you know, Docker registries, whatever it is. So that's really nice. Makes your life 1,000 times easier. Number 10, native support for Kubernetes, Helm, and Docker. And when I talk about being cloud native or Kubernetes native, I mean that this is something that goes beyond just like plugins, because a plugin is always working off of kind of the provided workspace. Whereas if you're built with these things in mind, it's a totally different ball game. It's going to operate totally differently. So I'll show you what I mean here in a second. We've always had like a huge focus on Kubernetes from day one. When we first launched, there was a big question if it was going to be Docker Swarm or if it was going to be Kubernetes. And after looking through everything, we looked at it and we said, I think Kubernetes is going to win. And we basically bet everything on Kubernetes. And that turned out to be a good bet. That was the right way to go. And we've been very happy with it ever since. So I'm going to show you really quick a little bit what that looks like. I'm going to go to Dustin's account. I think he'll have a great example in here. So I'm going to go to my Kubernetes dashboard. And this is actually going to show me all of my connected clusters, how they're connected, and then information about them. And I could see, for example, like what services are running, what their status is, their endpoints, what images they're running, if they've got any images attached to them, all that kind of stuff. And I can actually even get beyond that. actually, let me go over to environments view. Oh, he doesn't have one. Shoot. I thought Dustin had one. Let's see. Let me go over to switching to code fresh. Sorry, switching accounts permissions. Yes. This one and all right. So this one actually is showing GitOps environment view, and so you can see is all of the different services that are running, and I can see what image is currently running there. And if I click on that image, it'll actually show me a full history of where this thing came from. So I can see that Raziel is the one that made the commit. I can see this image has been promoted several times. And I can even jump straight into the commit SHA to actually see what code change has been deployed. So I'm actually looking at what's deployed right now. And I just went from what's deployed right now to the code in like 3 clicks. And this is a really big deal because a lot of times what people will do is they'll infer what's running because they'll just like, well, look at my automation and just be like, okay, that's probably what's running. And that might be accurate, but it might not. What if something was changed in production, right? What if somebody, logged in by hand or something, or some other process was connected or something else is going on? You don't have to infer, right? You want it to be completely visible. If there was a pull request here, I'd be able to see all the pull request information. If there were any Jira tickets or something, I'd see all those tickets here. And then I'd be able to see all the committers and stuff. So this is pretty rad. And then also being able to like execute, I can actually see what the load looks like on this one. And I'd also be able to do a pull request right from here. A rollback. And then we also have this idea of release boards. So these ones, well, let me go to a different one then. I should have double checked some of these environments before I went to go share them. What these do is basically allows you to define different environments, different Kubernetes clusters or things like that, and show you what's going on. And then assuming there was one here, I'd actually be able to, like, if I wanted to move it to staging, I could do that and it would deploy it over to staging, right? Now, ClickOps isn't necessarily the goal, but observability is the goal. So the idea is that you have something that's gonna cover the range of the skill set, right? So somebody that's a beginner can come in and they can understand everything that's going on and they can be useful. And then as you get advanced and you're ready to do it, you can move everything to code and then you just have all the observability and you know what's going on. And this includes doing things like rollbacks, actually seeing what's changed between different Helm releases and stuff like that. So this all goes to the point of kind of being Kubernetes native. And the other aspect to this is, capabilities. So if I look at the steps here, oops, the share bar is covering up my thing so I can't see it. So if I wanted to do a canary deployment, I can actually just grab a step that knows how to do a canary deployment to Kubernetes, right? And this is like practically drag and drop, right? If I want to do, like, let's say I'm using Argo and I want to do an Argo sync rollout and I want to do whatever interesting strategy, I can just drop that in and it's just a step that's available. And these are all open source again, so you don't have to use them with CodeFresh. You can use them anywhere. All right. So that was number 10. So number 11, SaaS on-prem hybrid installation options should all be on the table. So you shouldn't have to use it in the cloud. You shouldn't have to manage it yourself. You should be able to pick the solution that makes the most sense for you. And the big thing that I see with this is oftentimes companies will have things like PCI compliance, right? And they're like, oh, we have to run everything on-prem. Otherwise, it's a whole big pain. And so we just have to run it on-prem. And then you get in this situation where, like, maybe you're using like a subpar tool that requires a ton of management overhead. And it's really expensive and not everybody's very happy with it, but you're doing it because you have that hard requirement. So that's where hybrid comes in. And the way that hybrid works is really cool. Basically what you do is you install on your build infrastructure, the CodeFresh runner. And again, you could do this with another platform potentially. There are some platforms that support something like this, but you put it on the CodeFresh runner and everything that happens and stays on your infrastructure, but you can continue to manage it from the Saas. And basically there's no management overhead. So we actually have we have some customers that are doing PCI compliance that actually run this way, where they have everything on their build infrastructure. We have customers like, big financial institutions, banks, even some defense things, and basically people can run it on their own infrastructure, but they can manage it as if it's a SaaS. That's the hybrid model. And of course, if you need to go full on-prem, you can do that. You can install the entire thing on your own platform and manage it yourself. So that's also a popular option. But the hybrid is definitely the most popular because it's so easy and there's so little management overhead, and it does meet those security requirements in the vast majority of cases. So all the code, all the logs, all that stuff. It's essentially a zero trust operator for your Kubernetes cluster where builds can execute. Number 12, and this one's huge, zero configuration distributed caching. This is something that is very unusual. I see a lot of people who are like very opinionated saying, oh, caching should never be automated. I want to handcraft any caching that we do. And this one is so critical because speed is so critical, right? Like I talked about the speed and how critical that is. That's so important, and having it require zero configuration is so valuable because you just get it without a bunch of optimization. Now, can you do some optimization? Yeah, you could potentially do some optimization, but having it be zero configuration is a huge feature that's really valuable. So the way that we do this is, like I mentioned, every build node, it mounts the local SSD, and then it takes this distributed cache and pushes it onto each SSD as a build node goes to spin up. And this means that you get the super fast IO of a local SSD, but all the benefits of having the distributed cache attached into it. So it's really fast. Now, the alternative way that I see a lot of people do this is sort of the poor man's caching model, is they will fire up like an NFS share, right? Or like an S3 bucket, and they'll just be like, okay, I'll just attach everything there. And that works, except that now you have terrible IO compared to a local SSD. So if you're doing anything intense on that volume, it's going to be really slow. And B, now you have a persistence divergence problem where, like, if you have two builds happening at the same time because they're both working off of the same bucket, now they could potentially conflict with each other. That's a big problem. So by doing a distributed cache that fills the local SSD and then caches it back, that means you don't have conflicts. You have the isolation that you need. And I suspect that a lot of the people that were saying, well, you should have to config all of your caching by hand every time, they were probably dealing with these kinds of problems and saying, it's not safe to trust it. But having a local SSD with a distributed cache that fills it, that covers the problem. That makes it super easy. And there also should be rules. There are also rules around this, right? So like a potential attack vector on your CICD system is, if you have everything stored in cache, can I open up a pull request, modify the pipeline, and then spill all the volume and the secrets? This is was a really popular attack vector on a popular cloud CI tool from a few years ago. And it actually, probably a lot of you use Homebrew as your package manager. Homebrew was susceptible to this, and their repo, basically, somebody was like, hey, I got all your secrets on AWS, so you should change those. And so that was a bummer. So you definitely want to have like security policy built in around this cache. So having it be zero configuration, distributed cache that is also safe, that's really nice. And that's something we've spent a lot of time on. I mentioned this guy earlier, Ethan, from the company Hover. it was 2.5 hours to 12 minutes when they switched to CodeFresh. So that was pretty rad. And that was basically all this caching system that we talked about, plus some of the parallelism stuff. So this brings us to number 13, Monorepo support. Monorepo is becoming more and more popular. And I've talked to people all the time that are using Monorepo and they're struggling because their tooling doesn't support it very well. So a modern CI/CD platform should be really good at doing Monorepo. So this is something that we've definitely taken to heart. And especially if you're doing GitOps, it's especially popular. People probably know famously that Google does Monorepo, as does Microsoft. And that's a little wild because you're talking about a Monorepo that has like 2 petabytes of data in it. It's like crazy. And they've had to do a lot of specialized tooling to support something that large. But for infrastructure, it's really nice. So the way that we handle it is through the triggers, right? So the triggers, you can actually filter and say, based on when different file paths change, that's when you allow this trigger to move forward and execute, right? And so this means that working with the Monorepo is very easy because it's all based on the triggers, and the triggers carry the context, and then you can just have a pipeline that executes maybe for the whole Monorepo, but it just has different triggers to pull in the context, and so that the pipeline always knows what it needs to do. You can also say, okay, well, use this separate pipeline, whatever. So that's really nice. So Monorepo is number 13, and that completes our tour of 13 key features every modern CI/CD should have. And with that, we'll move into the Q&A period. And that's my timer going off that tells me that I finished on time. Nailed it. So with that, any questions or open discussion, or if you think it sucked, you can just message me quietly in chat or yell it, whatever. You know what? I can take some criticism. But yeah, thank you very much, and happy to take questions.
So let's say you want to run a hybrid installation of this. Is Kubernetes on-premise a requirement, or would something smaller like just a Docker, a machine running Docker running the CodeFresh agent container work? Or
yeah, I run it on my laptop.
Okay.
Yeah, I run it on my laptop in just the Docker desktop Kubernetes. That's been my favorite local Kubernetes experience.
Yeah.
And the installation experience, I mean, I'll just show you really quick since we brought it up. I'll just grab a terminal window over here. It's dealing with some internet issues earlier, as you can see. So let's see, what cluster am I even on? Oh, I'm not on it. I'm on my cluster that's at my house. So let me switch to this guy. So the way that you install the runner is just CodeFresh runner init. I think it's already installed, so it'll probably, it'll give me all my options, and I basically just run through this, and it will just provision it onto the cluster, and then you can actually see it in this namespace here. Now, this one's actually pretty rad because it's native to Kubernetes. This cluster is actually running off of a node pool that is only spot instances or preemptible nodes. So for any of those, if you're not familiar with that, preemptible nodes or spot instances on AWS are nodes that the cloud provider can take back at any time, and they never last more than 24 hours. And so they're super cheap. They cost like 90% less than using regular infrastructure. So to throw your build infrastructure on there is rad, because what this will do is I can throw a bunch of pipelines on this, and it will just spin up new nodes that are like 90% off dollars. And I still get all the performance that I want. And if it fails, it'll just retry it and it's fine. So this is like pretty rad. Yeah, good question. Any other questions from the crowd? Or from you, Greg?
You see me queuing one up, don't you? So what's the coolest non-Kubernetes thing that you've seen a client do with CodeFresh?
Ooh, the coolest non-Kubernetes thing. We do have people that deploy to VMs and stuff. Oh, actually, okay. Here's the coolest thing I've seen done. There's this really neat tool. I think it's called Geodesic. And this is used by a company called Cloud Posse, who's like the #1 contributor of Terraform modules. And what they do is they have this tool called Geodesic, and what it does is every time a pipeline executes, it actually gets a new set of keys for AWS that are only valid during the pipeline execution. That's pretty rad. I think that's super cool. Now, technically, I think that they are deploying to Kubernetes, so I guess it is Kubernetes related, but the key thing, you can just use whatever. Yeah, it's pretty rad. Well, cool. So unless anybody else has any other questions, I'll call it there. And hopefully that was valuable. Like I said, this is a little bit different than the talks that I usually do, which are more like, hey, we're going to talk about this open source tool or these best practices, and maybe there's a little bit of CodeFresh in it. This talk is really like, these are 13 features we think that are basically our guiding principles for why we built CodeFresh and how we do it. And so it is very like CodeFresh centric. And so hopefully that wasn't a surprise to anybody. Hopefully everybody felt okay about that, but definitely a little bit different than kind of the usual talk.